Okay, so today we're going to show that triangles are congruent by using side angle side and hypotenuse leg. On Thursday of last week, we learned about the side postulate. If three sides in one triangle are congruent to three sides in another triangle, then those two triangles are congruent using side. Okay, so side angle side is the next way we can show triangles are congruent. Now, over here on the side of my board, I'm writing a list of everything as we cover them, everything that we can use to show that triangles are congruent. Okay, you're going to need to know all of these. So, if you want to keep a separate sheet of paper on, like in front of your notebook or in front of your notes, somewhere so you can keep your list, that would be helpful. Okay, I've already written on there, side angle does not exist. Because remember we talked about the other day, to spell side angle backwards, what is it? ASS, and ASS does not exist. We don't have ugly words in geometry class, okay? Got it? It really isn't. Angle side or side angle does not exist in proven triangles. So that's just a really good way to remember it. We don't have bad words in geometry. Okay? I don't say bad words in geometry, okay? So side angle and angle side does not exist. Alright? So side angle side does exist. It says if two sides of a triangle and then the included angle of a triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent by side angle side. Now what it means by included angle, you got two sides you know are congruent. The included angle is the angle between those two sides. Okay? Included angle is the angle between two congruent sides. Does that make sense? So this one's congruent to this one. This one's congruent to this one. The angles between the sides are congruent. So therefore, these two triangles are congruent by side angle side. Okay. Lots of proofs. We'll give you a moment to draw the picture. The picture is important. We're going to use this picture and the given information to help us prove two triangles congruent. So the majority of what we're doing in this whole chapter is proofs. Proving triangles congruent. Make sure you draw the picture because your notes won't make sense if you don't draw the picture. All right, so if we're doing a proof, we got to have two columns, statements and reasons. And where do we get our first statement from? The givens, okay? You can do them both at the same line if you want to. Segment BC is congruent to segment AD. Are those marked? Is that marked on the picture? Yes, those little tick marks are marked, so they're congruent. So if they're not marked, you need to mark them. So those are given. And BC, what does those two lines mean? Parallel to AD. Now, is that marked on the picture? How do we mark that lines are parallel? Arrows. So do we have an arrow for BC and AD? Yeah. So if they don't mark congruent and parallel and stuff like that on your picture, then you need to mark it. So both of those are given. Again, you can do those as one step or two separate steps. So, we want to prove that triangles are congruent. Now, the only two ways we have proven triangles congruent so far is by side, 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 and side, angle, side. Well, we haven't proven side, angle, side yet. That's what we're starting with. So these are the only two postulates and theorems that we know to help us do that so far. So it's going to be one of those right now. Is there anything else that I can say is congruent in this picture? That's what we got to do. We only have one side congruent. So I either need some more sides or more angles congruent. AC and AC? Did somebody say that? AB and DC? How can I say they're congruent? Can't use that. Can't say that. You have to have a postulate, a definition, a theorem, or something to say something's congruent. AC is congruent to itself. Why? What's the reason? Reflexive property. So there's something I can say. AC is congruent to AC from the reflexive property. Now, what's something that's in the given that I haven't really said anything about? BC and AD are parallel lines, aren't they? So if we have parallel lines, and you look, AC is a transversal, right? Then I've got all those parallel postulates and theorems, right? If I have parallel lines, then I have alternate interior angles, alternate exterior angles, consecutive interior, all those things. Okay? So, if these two are parallel lines, then I can say that this angle C is congruent to this angle A because of why? They're alternate interior angles, right? So there's my next statement. Angle BCA is congruent to angle CAD because of their alternate interior angles. Now that's why you cannot forget anything we have already learned in geometry. It just builds and builds and builds. Chapter 3 was that. As many as it needs. We're actually done. Except for the last one. Okay? So you cannot forget anything we've already learned. Because yes, we need parallel line stuff in congruent triangles. Okay? Now let's look at what we got. Oh, let's scroll down. Sorry, y'all. I can't reach my top of my screen. This segment and this segment are congruent, right? This segment is congruent to itself, and the angles between them are congruent. You see that? Congruent, congruent, congruent. Y'all see that? Y'all weren't looking up here. Some of you weren't. Do it again. Congruent, congruent, congruent. Two sides congruent with the angle between them. That is side, angle, side. Okay? In order. Sides, angle, side. The angles are in between the two sides that are congruent. Okay? So now I can say those two triangles, ABC, is congruent to CDA because of side, angle, side. Triangle. Make sure you write them in the correct order. Is congruent to triangle CDA. Side, angle, side. Congruence postulate. So that's it. Look for reflexive. If they tell you parallel lines, then look for alternate interior, consecutive interior, all those things that you know about parallel lines. Okay? Good deal. So it wasn't so bad. Next one. I'm going to give you time to draw that picture and write down that information. That picture looks like a Pontiac symbol. Do y'all know what a Pontiac is? Yep, they don't make those anymore. Hey, they lasted forever. They were good cars. They would run forever. My sister still drives one. It was a G8. It was, yeah, the last model. Her G8 is nice. But you can't get parts for them anymore. They don't make them anymore. But those things will run forever. They're good cars. Mm-hmm. She had a Grand Prix, and then she got the G8. She drove it forever. I know, for real. My first car was a Saturn. They don't make those anymore either. Let me tell you what, the one that I had still running. I sold it to my dad, and he gave it away to a guy at his church that needed a car to get to his job, and that thing is still running good. Well, I bought it from my dad, and I sold it. It is. Yeah, the thunder's shaking it. Hush. Okay. Yeah, mine aren't either. My last example has these on it. So I'm going to do my statements and reasons. We're proving something, so we got to do statements and reasons. What's my first statement, y'all? Now, does that one marked on the picture? Did they mark MP and NP congruent? Yeah, those little tick marks, so they're congruent. And segment OP bisects angle MPN. Now, those two things are given to me. Now, what does that mean, that it bisects it? Well, it's an angle, so it's not really a point. OP bisects MPM. NPN is that bottom whole angle. So what does bisect mean? Cuts it into two equal pieces, right? Right? So what can I say about these two little angles right here? They're congruent, right? And that's the whole point of me proving triangles. I'm trying to show that different pieces are congruent, right? So that way I can show the triangles are congruent. So I'm going to mark them. And so I can say angle MPO is congruent to angle what? NPO. Now, why can I say they're congruent? Because of the definition of a what? Of an angle. I'll do it like this. Bisector. Bisector means it cuts it into congruent pieces. Exactly in half. Alright, is there anything else in this picture I can say is congruent? Because I've got sides congruent and one angle congruent. I need something else congruent to use triangle congruence. Say it again. Can't say anything about those. Because it said it bisected this angle, it didn't say it bisected that angle. OP, segment OP is congruent to itself. Segment OP is congruent to itself because of why? Reflexive property, very good. So I can mark that one congruent to itself. Now what do I have? Side, angle, side. So now I can say the triangles are congruent because of side, angle, side. Does that make sense? Triangle MOP, MOP, is congruent to triangle NOP. Okay, so yeah, they didn't tell me that angle MO, anything about angle O was bisected, so I could not say those. Okay. But if I could, I would use angle side, which we don't know yet. We good? It seemed fairly easy. You just got to get stuff congruent. And then once you have 3 things, you can usually prove the triangle's congruent. Okay, this one's not a proof. Not a proof. Just ask me a question. It said, here's a picture. It's outside of the circle. It's got 2 lines that go through the circle. M is the center of the circle. It says segment QS and segment RP pass through the center M of the circle. That means this is the diameter and this is the diameter, right? Because that's the definition of a diameter. It goes through the center of a circle, and it's a chord, which means it's on the edges of the circle. What can you say about triangle MRS, which is this triangle MRS, and triangle MPQ? What can I say about those triangles? How? Prove it. Okay, but I have this triangle is over here, and this triangle is over here. So I have to show I either know side, 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 or side, angle, side. So I got to have 2 sides congruent and 2 angles congruent to say that it is. Sorry, y'all. Hang on. Mine took me to chapter 1. I meant to put this line back on there. Okay. So I've got to prove that either all 3 sides are congruent or 2 sides and the included angle are congruent. Okay? So what? Okay, well, if M is the center of the circle, isn't that the midpoint of that segment? So that would mean this and this one are congruent, right? Same thing, right? If M is the center of the circle, that means M is the midpoint of that segment. So that would mean, they're really shaking my projector. This one and this one are congruent, right? Does that make sense? Now, to say that these triangles are congruent, I either need to say these sides are congruent or these angles are congruent. Which one can I say? With what information? You can't just say it looks like it. You got to have some hard evidence. Well, can I say anything about these angles? They're not congruent because the sides are equal. Why are they congruent? Because that's what congruent means. But why? What is their relationship? They're vertical angles. Y'all gotta know that. They're vertical angles. Across from each other means they're vertical angles. And we have learned that vertical angles are congruent. Equal measures. Congruent. Y'all know what a vertical angle is? Y'all have got to, everything we've talked about, you have got to remember in some capacity. Vertical angles being a major one. Okay? So these 2 are vertical angles. Y'all see that? Y'all see that? So, now I've got what kind of congruence? These sides are congruent. The angles in the middle and these sides. So that's what? Side, angle, side. So I can say triangle MRS is congruent to triangle MPQ because of side, angle, side. Okay? You can't just say they are because that's what you're trying to show. You have to know why. You got to have reasons. Okay? Yeah. Yeah. But I wouldn't do that till like a test or anything. All right. Let's talk about right triangles for a second. What do we know about a right triangle? It has to have a what? A 90-degree angle. One of the angles has to be 90 degrees, okay? So, to make up of a right triangle, we have 3 sides The two that form the right angle are called legs, and the long side that does not touch the 90-degree angle is called the hypotenuse. We've heard that before, haven't we? We've heard that before. You probably even heard of a squared plus b squared equals c squared, right? Okay. So, basically all you need to know for today's purposes is that the legs touch the 90-degree angles and form the 90-degree angles. The hypotenuse is the long side of that triangle that does not touch the 90-degree angle. Okay? So, we have one more congruence postulate. This is actually a theorem. And it's on the back, on the top. So turn to the back of your handout. The very top one is the hypotenuse leg congruence theorem. You don't have to write it, but do highlight it. Yeah, I took it up. Okay. Most of the time. Okay. So the hypotenuse leg theorem says, now y'all listen, this is for right triangles only. Make a note of that. Right triangles only. If it's not a right triangle, meaning you don't have a right angle in it, you cannot use hypotenuse leg. If it's not a right triangle, you cannot use hypotenuse leg. If you cannot prove that there's a 90-degree angle in there, you cannot use this theorem. It won't work. Okay? If the hypotenuse and how many legs? A means what? One, singular. If the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg, one leg, of a second triangle, then the two triangles are congruent. So if you know your hypotenuses are congruent and one leg each are congruent, then you can say your triangles are congruent using hypotenuse leg. Let's do this one. Okay, now y'all, those things that look like twos are Z's. Okay? It looks like a 2, it's a Z. I apologize, I do terrible at Z's. I should. But some people are like, why'd you put a line through it? I have complainers no matter what I do. Y'all like that better? And then people say, that looks like Japanese. I can't please everybody. So draw the picture. Now, what does that mean, those upside down T's? Perpendicular. What does perpendicular lines do? They intersect to make what? Right angles, right? Well, if I have right angles and they're inside of triangles, then I have right triangles, right? Right? So you see where we're going with this? Yeah. Might be something helpful. So I'm going to do my statements and reasons table. How many givens do I have? Technically 3. So I do all of mine in one step. They could be in 3 different steps. Oh, sugar flipped. So, and they did not mark anything on my picture, did they? Did they mark anything given to my picture? Okay, my pen is not writing. What is up with this? It's not writing. Seriously. Stop. Hello. Like, completely is not writing anything. Okay. I got backups. Yeah. Bobby Joe bought me one. Because he loves me. Okay. See if this works. Well, this one isn't working. Must be the program freezing. The program. Seriously. Okay, it's not letting me write. Yup. It's not letting me write. Hang on. Like it's working. Sorry, I'm trying to go out and then go back in, see if it lets me write. Hey. It's the program. Great. It's the program. Okay, we'll do it this way. Yeah, I know. It's letting me do stuff, but it won't let me write. I don't understand. All right, y'all fill in all your givens, please. While y'all are waiting on me to see what my technology wants to do. Yeah, still do all your statements, and the reason is given. It'll let me do anything except for write. So I'm sorry if you're watching this video and it's not working on me, and you'll just have to get these notes from a friend. Have a good day.